Welcome to Flat Earth Debate. I'm your host, Nathan Oakley, and if you are new to this channel, or you are one of the 50% of the people watching this that have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you would like to support this channel, there is a super chat that runs alongside the show while it is live, and if you would like to join the debate, there is a link in the info box below this video. With the page you are listening to me on now muted, simply click that link to join the discussion and express your views on the shape of the Earth. There are a couple of rules in the Hangout. Number 1, please do not swear. If you do, you will be ejected. And if you are, please do not try to rejoin the stream using sock accounts. You will be warmly welcome back on the next stream. Excuse me, you little munchkin. You're going to help me do my intro? Come on then. Come and help me do my intro. Come on. In a moment, I'm going to transition across to my photos so I can share the show on Facebook, Skype and Twitter. And I would encourage anybody who is in the live audience to please also share the show. It's very important that you do, as sharing the show obviously increases the live audience, but that in turn increases the chances of a more diverse panel. So, let's just have a look. We've got somebody in called something I don't like, so let's immediately boot them. Right, so, as I say, I'm going to transition across to the Hangout as opposed to my photographs. And one last time, if you are new to the channel or you have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. Now, we have been joined in the Hangout by Arwin. How are you doing, Arwin?
Hey, I'm doing great, Nathan.
Excellent, excellent. Good to have you here.
Yeah, hearing a bit of an echo. Oh, no, it's gone.
Yeah, that'll happen for the first few seconds you join, but don't let it phase you. Well, my friend, you've got the floor. The mic's all yours.
All right. Haha, it's flat. Probably, most likely, 90% sure it's flat. That it's perfectly flat, at least. But yeah, it's definitely not a globe. And yeah, I talked a bit about spatial density in my own hangout that I had yesterday, and referenced the flat Earth debates as well. I hope all of you people out there in chat have also watched that, because it was kind of my thing, uninterrupted for once. It's very nice. Yeah, I think things are really getting interesting. I think we're cracking the illusion piece by piece. It's becoming more fragile, and well, let's see what comes up next. Maybe somebody can get an even clearer photograph set than what was his name again? Got yesterday. Is it Ranty?
Yes.
Huh. Yeah. So who knows how far actual clear skies can bring a person? Would be, yeah. Who knows? But yeah, there's still the thing about the radar, because I heard this through Mark Sargent, through one of his military viewees, and that guy, or he explained how he heard it from him. I don't remember which one it was, if it was him speaking directly or just reference, that the military is using a radar system that can reach at least hundreds of miles and potentially thousands even on a clear day, if I remember that correctly. And well, if you just figure out how radar works, that's actual sound waves that reproduce through the air mostly, or through any medium. Yeah, if it was on a globe, then eventually the curve would get in the way. You wouldn't be able to reach that far. So, unless you were upon a huge mountain. So, yeah, that's just another thing. Technology can be very hard on religion.
We've been joined by Epistemology for Truth. How you doing? Good to have you here.
So I listened to the show this morning and noticed after doing some careful analysis of the reason for the anomalies that we were seeing. And the answer isn't refraction. I can go and show you my analysis here.
Okay, did I get it wrong?
We want to wait for if Riley is coming in or Randy.
People are saying that radar is not sound waves. Is that correct? Is it something else? I thought it was type of sound, basically.
No, radar is electromagnetic waves,
Oh, okay.
just like your microwave.
All right. Yeah, well,
But
my mistake
Like
then.
ultrasound, when you get like when they're looking at a baby, that is sound waves.
Yes, and sonar. I'm pretty sure about that.
Yeah, sonar is also sound waves, correct? Yep.
Yes. Oh, by the way, I heard that sonars can also reach incredible distances.
Like in water, especially, it can propagate huge distances in water.
Yeah,
That's
pretty
what the
amazing.
that's what the military uses for submarines, fishing out submarines, and
Yep.
detecting mosquitoes and stuff like that.
Mm-hmm. But pretty bizarre that could reach so far. Like, yeah, with curve and everything. That would kind of count at the sea bottom the same way.
The curve wouldn't impact.
Really? How does that work?
It's a continuous medium. It's a continuously dense fluid that it's passing through. So.
And the fluid bends the sound with the curve. Why exactly? I would like to compare this to fiber optics. Really, it's like a light bouncing within a medium.
Been joined by, sorry to interrupt you, Epistemology. We've been joined by Infinite Time. How you doing, Infinite Time?
Hello.
Good to have you here.
My name is Jaspal.
Say again?
My name is Jaspal.
Your name is Jazz?
Right. You can take a hose and you can stick it in your ear, and then you can speak into the hose. I don't know if you ever done that as a kid.
I am a flat earther.
Yeah, but that's because of amplitudinal waves.
No,
It's a separate effect.
Travels through the air in the tube, and it goes around in a
because it's enclosed in that shape. The amplitudinal effect will cause it to go with the shape.
What amplitudinal effect are you talking about?
Well, sound like moves in basic sound.
It's just
regular
the
sound. Music
the
moves
air
in two types of ways: through the snare effect and through amplitudinal waves, which is more pressure based. Like that's how speakers produce sound, by pushing the air in the exact frequencies.
I don't know what you're talking about with snare effect. I'm not familiar with that as any kind of.
I'm not talking about particle physics or anything. I'm talking about sound. We're talking
about sound here, and you're saying that sound travels through snare effect, which I don't really understand. What is snare effect?
Well, like a guitar, the snare instrument, for example. The snare is a way that sound can travel through a physical medium, and causes the effect that you see, or that you hear. You don't see it really.
But the sound is the sound is just vibrating air. I don't know what you're talking about snare effect. The reason why you can hear it is the air is vibrating. You take away the air, there's no sound. Right? People do that on YouTube, and they're
no, that's correct. Absolutely. Never mind. I don't even know where this started.
I do want to go back to the analysis problem that we were having this morning with Isle of Man, so that we can finally put the nail in that coffin.
I don't know what it was about, really.
So the problem is that the way that they cropped it is there were huge, especially on the left side of the image going towards the southern end of the island, there was a huge amount of repeating land that was clearly obvious in the panorama. In fact, there was a white pixel in there that you could see was repeated. And when you lined up the pixel, you could crop out a huge amount of land that would line up perfectly. As well as some of the structures on the hillside, you could see that they were clearly repeating. And so I made a corrected image of that landscape and shows how much extra land they were adding to that. So let me put that in first.
Oh, so you're saying it was
There
falsified?
we are, in. Sorry, we've been joined by the Rumpus. Good to have you here, the Rumpus. Good to see you.
Oh,
Thanks for being here.
Well,
yeah. I'd just like to back up what epistemology is. Earlier today, I did exactly the same thing. It's a horrendous composite error in that image. It's just ridiculous. And like him, I've reconstructed it and moved it to about 50% of the last 2 frames are actually duplicated just about, where they should be overlapping. You can see from the cloud formations and other things, they've made a complete cock-up of generating that composite image.
You can tell how screwed up the frames are depending on how sudden the contrast is between frames. If you notice, one frame is suddenly much darker than the other. Since this was taken from a video feed, not from a camera with different setting between shots, you can tell that when there's a big change in the light and darkness, that the frame was not properly cropped together or put together.
Yeah, that indicates as well. But you can just see the clouds. I mean, if you just look at, how on earth he thinks he's composed that? You can see from the cloud formations and from the line of houses that he's duplicated them. He hasn't overlapped them properly. I mean, honestly, absolute idiot. And that dismisses. I mean, I did actually have a presentation. I was just in the process of doing, but given that you seem to start the Hangout now, I haven't had time to do it now. But I was going to show exactly what the changes you have to make it into a sensible image, and of course, it invalidates the idea it's Ireland completely.
Yeah. So I'll show you what
Why is level? Why does the water always why is level every single time? Why does the water do this every time?
Because gravity pulls it to the surface of the Earth, and that is a sphere. It's dependent on its distance from the center of the Earth. Therefore, level is still curved.
Right.
I mean, I can show a quick diagram of that effect before epistemology gets into his presentation, if you like. I've got a little diagram here that demonstrates this very point. Yeah, I can share this.
But anyway, as you're searching for that image,
I've got it now. Here we go. So if you can see that image here, if you think of someone observer here of this image here, the distance is the same distance from the Earth, center of the Earth, is followed by this curve here, and all those points are at the same level. So water would occupy this circumference, and it'd all be the same distance away from the center of the Earth, yet it is it's an arc of a circle, but it's always the same distance from the Earth, it's always at the same height. So there you go. So it's very, very easy to explain.
Absolutely ridiculous.
Is that spherical trigonometry or some shit?
You don't like trigonometry now, do you? That's your objection, is it? You've decided that trigonometry is invalid as well as the spherical Earth. Well done.
No, it's not invalid. It's just not.
It's just not
usable to.
It's just not usable. You can't use trigonometry on
bodies,
circles. You can't use
works
trigonometry
perfectly on the world.
Flat circle trigonometry.
You're questioning trigonometry. There's no end to how idiotic you're going to be.
Yes, of course.
There is no end.
We only spent, well, what is it, like 7 Hangouts referencing about it. Just so ludicrous of me to bring it up again.
Bring what up again? What exactly is your complaint? You don't understand how circles work. Is that right?
No.
You do understand how circles work. Okay, in which case, fine, you shouldn't have a problem then. Either you do or you don't understand how circles work. If you do understand, then you know exactly how the spherical Earth works. If you don't understand, well, I'll get a 13-year-old to come and assist you, because some of the understanding I've seen of people on the flat Earth doesn't seem to match a 13-year-old.
It's not that's not related to reality.
It's exactly
related. Curvature.
It exactly fits reality. You can check this empirically, go out and observe it. We have even pictures from space of this very same thing.
Oh yeah, those are so reliable.
Yeah, absolutely. Of course.
Yeah, no, they come from NASA. I know, it's
that's
lovely.
good. Right. Yeah. And also, not just from NASA, but from
Are
all
there-
other space institutions as well. Japan, China, India, Britain.
Yeah, I know. They're all part of the same system.
Oh, there's all worldwide conspiracy. So everybody
Yeah,
else is on the
yeah, it
conspiracy
is.
with you. So everybody's in on
They
this.
are all
Millions and
Yes.
millions and millions of people.
They are all
Yeah.
satanic
You are in on
cheeseburgers.
this conspiracy. Excellent.
They are all satanic cheeseburgers.
It's a form of government.
Right,
It's
so
an
the-
extra
so-
system to
so
get
even though
a
there's
huge sum of
ideology-
money.
While you're all talking over each other, I'll just turn you all down so I can do the next introduction. So we have been joined by Stiggy. Very pleased to have you here, Stiggy. Nice to see you.
To see you too. Keep it going, gentlemen.
Yeah, right. But I mean, we're getting a bit distracted from the Isle of Man here. But I mean, we seem to have someone here that's questioning trigonometry, which impresses me as to the
No,
depth
I'm not
you will think.
questioning trigonometry. I just figured it out.
Trigonometry is fake.
Trigonometry.
No,
there
it's
we
not
go.
fake. It's not fake, but it's
Trigonometry
a
is fake.
trick
This is
formula.
the level of the people we're dealing with. Here.
Trigonometry is just a mathematical language
Is that you, Pete?
created
Is
inside
that
your
you,
head.
Pete Shea? Is that you, Pete?
Yeah.
Oh, too late. I booted you. I'm sorry. Not quick enough. Oh, sorry, Pete Shea.
I mean, I'm happy to talk about trigonometry, but I don't want to stop epistemology doing his the Isle of Man stuff.
Yeah, of course.
So
Well, it is interesting when your trigonometry can't explain why certain things are seen so far away. Then you say, "Well, it's refraction. It's
It can.
refraction."
Indeed, refraction is a lot to do with this, and I was preparing a whole thing on this, but as I say, this is a bit earlier than I expected, so I haven't got that quite ready. But I can go into the principles.
Rumpus,
That's
can you
okay.
can you share that picture?
Yeah,
from
no,
the group?
I've heard the whole.
Can I do what? Sorry, epistemology.
Can you click that link here in the group chat and share it?
Okay. Right. Okay.
Big shout out to Pete Shea. So sorry I booted you. We've had so many troll Pete Sheas. Sorry.
Oh, I need to open another. Oh, sorry, I'm. Oh, sorry. I'll have to go. I've got to open another.
I haven't seen you for a while, Stiggy. How's things?
Very well. I just got back from a lovely trip in Latin America. Got to spend some time in Nicaragua.
Nearly there, epistemology.
Did you meet Spaceman?
There we go. If you can see that.
Did you ask me a question about Spaceman?
Is that okay, epistemology?
Yeah, can you zoom in on the
Give me
left
the
side
link.
there, the last 3 frames there?
Can I do what? Sorry.
Just zoom in on the left here on the last 2 or 3 frames.
Okay.
Just go ahead and click in there.
I don't know quite why. I seem to have some 2 white blobs
Okay.
here.
Yeah.
I'm
I
just
did that on
wondering if
purpose.
That's
you're
fine,
now
is it?
actually
Okay.
using his original picture, or this is your fabrication.
No, this is from the original picture. You can. I
Oh,
can link.
indeed. Here you are. And here you are. I can do what? Sorry to interrupt you, epistemology. Here you can just see the level of idiocy. This cloud formation here, that is the same tip as that, and you can see that this is the same shape as that. So this is.
No.
Yes, it is. Yes, it is. That is the same shape as that, and this is the same.
Yeah.
No, only
It
partially.
is. It is. It is. If you go and bother to look at it,
Yeah,
No, look,
you
the
haven't
look
looked
at
at
a
it
lot of
left one has
properly.
like a slightly darker part
You
within
haven't
it.
looked at it properly. Both epistemology and
Look
I
at the
have,
features,
and I
even-
can assure you it's an
Even
error.
from like random white pixels and things, you can see them replicated. And so what I've done here, these little
Yeah.
squares, I just wanted to demonstrate. If you pan over to the left for me there,
Right.
real quick.
Okay.
Go all the way to the left there.
Okay.
Okay, so the beginning of that white box was where the land was claiming to be actually ending. But in reality, I had to shift everything over this far to the right in order to start getting the pictures to actually line up correctly so there's no duplicated land.
That's right. And of course, the claim that Riley made that this thing over here was Douglas is, of course, completely incorrect. Douglas is actually here. I don't know if that's what. Sorry,
Douglas is actually below the horizon, Rumpus here. I want
Yeah.
you to click on my analysis. Hold on one second.
Yeah, sorry, I shouldn't preempted you because I've got a picture like this where I've actually highlighted the various places. So Riley got it completely wrong as to what he thought he was looking at. This is something beginning with B. I've forgotten his silly name now. The actual thing he thought was Douglas, because Douglas is somewhere over here. So that's why and then of course he's got the composite wrong. I mean, it's just so full of errors. It's just untrue. But it doesn't. But that still doesn't change the fact that even though this isn't on, we've still got the issue, of course, of explaining how we can see areas that are.
Click that second picture there.
Sorry.
Click that second link for me there now. That says
right.
Isle of Man analysis.
Okay.
That second link that I just posted.
Okay. Give me a chance.
This is satanic. This is some satanic low worshipping shit.
Here we go. Can you see that epistemology?
Okay, so I did my best here to try to match up the features. The problem is some of the stuff on the right, he overcropped it a little bit. You can tell by the sudden change in the shade between light and dark when it was a little bit overcropped. And so it's slightly truncated.
Right.
And so
yes,
you end up getting
fix that, of course. Yes. Good point.
You end up getting a little bit slight. The proportions go off a little bit, so your little landmarks start to kind of move around a little bit. But it's close enough that we can pretty much tell what we're looking at here. And the first thing that you'll notice here is, you can see where Bala Canal is, which we identified as the city that originally he was claiming as Douglas is actually Bala Canal, which is a city that's about 500 feet up, which makes sense why it's pretty much on the water in their photo. So that's what that red box is there. It's Bala Canal. Yeah. And then there's a very, very, one of the most noticeable features on his image is there's a ridge line with a bunch of structures on it, which is that red squiggly line there. So I lined that up with Google Earth as well so that you can see that ridge line there. And so that makes it very obvious that that is Bala Canal on the left, and then that is that ridge line there. And then I just drew little lines showing all the little terrain
squiggly wiggly?
All the little squiggly wiggly lines that Stiggy likes to comment on here. That I've marked all the little points on here to try to line this up as best as I can, and it's pretty close. It's probably off in a few little spots because of the fact that, like I said, it's a panorama that wasn't perfectly constructed.
Yeah, because I don't think this is not. I think that's not
correct. It kind of on the right there. It goes off a little bit.
Yeah.
Sorry, guys. I'm just going to do a very quick introduction. Sorry to interrupt you.
Because it's truncated there. But
sorry, epistemology. I just want to say a quick hello to Curved Water. Bear with me. Just need to say a quick hello to Curved Water.
That's right. Yeah.
The left-hand side, guys.
You're noticing
guys, are just completely ignoring me. Hello. Hi, Curved Water. How you doing? Good to have you here.
Good. Everybody needs to acknowledge that I'm here now. Thank you.
Okay.
Excellent.
Yeah, Pismage, I agree with you. Once you can fix the left-hand side because he's overlapped them. Sorry, not over because they're not overlapped correctly. So you can fix that, but you can't fix the truncations that occur on the right-hand side. Yeah.
Right.
It's a complete mess. I mean, utter mess. I mean, a 13-year-old could have put this together better.
One thing is, after we corrected the panorama to the left here, you can see that the land quickly droops off, and I drew a line there showing the end of the visible land. And in reality, if we look at the Google Earth where Douglas is over the horizon. It's actually just water over there, which makes sense because you guys were asking, well, how can we see any of that land? Because it's all lowlands. The southern and the northern part of the island is lowlands.
Yeah, I'm not. I'm not completely in concurrence with your. I think that mountain there actually matches that because mine I actually had them coming together quite nicely on the end, and you've got them missing quite a bit.
Yeah, the left part is incorrect. It doesn't look like that at all.
I think epistemology you'll find that mountain there is actually that one there, and I don't think you've got this one.
It can't be because then the ridge line won't line up.
Well, I think. Are you sure you're not getting confused with this ridge here? I mean, you might be right, but I just think mine matched up almost exactly with the width that he had, and I managed to get a good match on the left-hand side. But yours,
trust me, I played with this thing for hours. You won't be able to get that ridge line to line up. That's the most prominent feature with the structures on that ridge line, and that ridge line goes up.
Yeah, I mean, I just
matches with Bala Canal.
I did some color correction on this to try and emphasize this thing, but yeah, I haven't finished it, so I'm not. But I managed to get on mine anyway. I managed to get my left-hand side matched exactly the Google Earth left-hand side of the Isle of Man, whereas yours isn't. And it seems to me
you have to keep in mind though. I shot this. I did this one a little bit higher up to get more of the terrain feature.
Right.
So
what altitude?
I don't remember what, but I purposely
I tried to keep it down. I tried to keep it down at about 30 meters.
Okay, so that might be why. That might be why. So you might have already been communicating.
Epistemology.
Yeah.
Are you working with the one that, like, did you alter it from what Ranty did?
I corrected that section that I showed.
Yeah, so this is a corrected one, isn't it? You're saying epistemology. This image here you're showing is the one you've corrected.
Yeah, I've corrected it. You can tell because you can see where I split.
That's going to have an effect.
Actually, epistemology, I don't think you've corrected this quite correctly because you can see this cloud again. That I think I'm not.
No. What you're missing is I left that. See, that's the whole part. That's the whole part about it. is if you look and see underneath, you can see where I've moved the land masses over.
Oh, I see. You've moved this bit. Oh, right. You've left the sky in place, but moved the land. Right.
I left the sky in place. Yep.
That's right. So so that's why there's still an error with the clouds, right? Okay, which I then fixed. Okay, I moved everything. Okay, fine. Yeah, I wondered why there was breaks at this level and not at the other level. Right. Okay. Yeah,
that's where I had to move it over to line it up.
Right, so you can see how much you've had to move it over here. Yeah, that's the amount I had to move over as well to make it mix. Yeah, you can see the huge. I mean, it's 50% wrong. I mean, it's 50% wrong here. Oh.
But the important part is this whole left side, you know, there's some bluffs in front of Douglas, which is probably what we're seeing there. And there are some tall mountains that are in the line of sight that are a little further back, which we're seeing on the very, very bottom of the horizon. But there's no way that you can see actually Douglas or all the lowlands, which makes sense because yesterday Riley admitted that we cannot see the lowlands to the north side of the bluff. I'm like, well, why can't we see the northern lowlands? Because that's only 30 miles away, yet you're claiming we could see the lowlands around Douglas, which is 50 miles away. That doesn't make any sense. And really it doesn't. When we look at this analysis, we can see that that whole side of the island is actually over the horizon, because the visible land ends before where we would expect Douglas to appear.
Yeah, you can't see Douglas at all, as you can say. You can see a tiny little blob, because of course, as we can see from Google Earth, you can see the great little mountains in the way, and it's all at sea level. So there's no way you're ever going to be able to see it. And so of course, Riley then said, aha, he found this image wherever it was here that he found, which was the Balakanal, and thought, that must be Douglas then. And of course it isn't.
They've been joined by, sorry to interrupt you, Rumpus, we've been joined by Sleeping Warrior. How you doing?
I'm all right. I've just had your message saying that you're alive. I didn't get the notify saying that you were alive, and you're a lot earlier than what you normally are. So I kind of didn't expect you on for another hour or so, too. So apologies. What have I missed?
Everything, Riley. This Anthony. This image. Is it who composed this image?
Ranty.
Is it Ranty?
Yeah.
He made an absolute hash of it, and you can see here from what epistemology has done. You can see the error. I've actually done the same thing as he's done. I've got the same error. Shown the same. It's 50% wrong on this one. It's about 20% wrong on this one, which means the image has got it far extended over to the left more than it should be. You've also misidentified where Douglas is. It's not here. That's Balakanal. Douglas is obscured, and if you use this image correctly, you find out what you've been identified as Douglas is in fact this Balakanal, or another place called B close to that. You've completely misidentified where things are, and it's clearly, and my image when I've done it completely matches the Isle of Man. This is definitely all of the Isle of Man. You and Ranty together have completely made a hash of this.
I don't think so. Ranty's lined up all of the dots there.
No, he hasn't. You look at the cloud formation. You go and look at the left-hand side, and you'll see clouds are duplicated. And you can see what epistemology has done here. You can see the error or the overlap. You've got these hat entries. And I had to do the same thing. And it's so obvious. A 13-year-old could see that it was incorrect if you go and look at it properly. An absolute hash of it.
Whose is this composite?
This is what epistemology has done, so he could talk to you about what he's done.
Oh, hang on. Let me see if I can get hold of Ranty. I'll have to ring him because he's obviously I didn't know that he was live, and I don't think he'll know. Let's get Ranty in and see if we can. You can put your allegations of his mistake to him.
It's absolutely horrendous. Absolutely horrendous.
Hang fire. Let's just see how horrendous it actually is, because I'm sure there's a totally plausible and normal reason for it.
Both epistemology and I have analysed these images. We both come to exactly the same conclusion. It's so obvious from the cloud formations.
Right. So, what is the allegation that he's fudged it, or has he made a mistake? Or
I don't think he's lying. I don't think he's lying. He's just made a complete and utter hash.
All right. Let me ring him.
Just while you're ringing him, I have a question. If we're standing on the shoreline.
Hold on, Stiggy.
Hold on. I just want to say hello to one more new guest. We've got Paul with us. Good to have you here, Paul. Nice to see you.
Hello, Paul.
Hi, guys.
Good to have you.
I'm tired too.
So if I'm standing on the shoreline and I'm looking out at a boat, is my horizon farther from left to right than it is away from me? Does that make sense?
No, your horizon is the same in all directions.
If you're on the water,
you're saying
if you're on water. I mean, obviously, if you've got hills and things, it's going to vary. If you're on net, if you're looking over water, the horizon will be the same. Provided, of course, you're looking, you're not to one side or something, you're not leaning your head or something. If you're just looking straight ahead and you've got the horizon sort of as a horizontal in front of you, all these stuff to the side of you will also be the same distance away.
Well, you're saying, okay, so you're saying the distance away from me, I can see about 13 miles, and then all the way.
No. If you're standing on the seashore and you're 6 foot high, you can only see 3 miles away.
Okay, 3 miles. 3 miles away from me. But
Oh,
what
man.
about what is the horizon all the way to my left and all the way to my right? How many
All
miles
3
is
miles
that?
away. So it forms a big circle around you 3 miles away in radius.
3 miles total.
In radius. Yes. You've got to, in other words, you're surrounded by a circle.
Okay.
And that circle has got a radius of 3 miles. If you're standing, if you're 6 foot high and you're looking over water, you'll have a radius of 3 miles all the way around you.
Okay, and that limit of distance is because of our eyesight?
No, it's a curvature. You can see stars. You can see stars billions of light years away. It's the fact that it's curving.
Wait. 3 miles is that's the actual curve.
For someone at 6 foot high, you can only see 3 miles. With the horizon is 3 miles away because you're only 6 foot. If you were twice as high, the horizon would be much further away.
So what if I'm standing looking at a mountain? Is that mountain actually curved down?
Right. Yeah. If you're looking at a mountain, then that will obviously be more visible. Because we're talking about at the surface, something at the surface of the Earth height. I mean, I can do the calcs if you want to put in a particular mountain. But yes, obviously, if you have a mountain that's sticking up, you'll be able to see that from much further away. Yes.
That's contradicting, though.
So I'm going to run a few links with the audience. If you've not done so already, please share this show, as it does increase the live audience, which in turn increases the chances of a more diverse panel. So please share. If you're new to the channel, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth debate. If you're enjoying these live streams, please toss me a buck or two in the super chat, which runs alongside the show while it is live. And most importantly, if you would like to join the debate, there is a link in the info box below this video. With the page you are currently listening to me on muted, simply click the link in the info box to join the show and express your views on the shape of the Earth. There are a couple of rules in the Hangout. Number 1, please don't swear. And number 2, please don't try to rejoin if you are kicked for swearing. You will be warmly welcome back on the next stream. And once more, if you're new to the channel or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth debate.
At the moment, they can't see it.
He's
if I was to
gone.
move the building nearer, he's gone, is he?
He's gone.
Oh, okay. Well, God, honestly, how is this some sort of educational? Is this some sort of special needs educational hangout or something? Jesus Christ!
It was
Stiggy get sniped to take it.
Do you remember Stiggy?
No.
He's just here to make a mockery of things.
Right, so epistemology is in the middle of it. I'm stealing epistemologist. I mean, both have them, but epistemology is the one who's.
Can you see my screen now, guys?
Yeah, we see.
Who is this twat? Can't we get rid of this twat?
You'll get kicked for swearing, and I want to talk
Trolling.
to you.
As long as he's not swearing, he's all good.
No.
I think he's referring to me. I think he's saying that he's warning me that twat is a swear word. I think is what he's trying to say.
No,
Yeah.
that's good by me.
Okay.
I'm honest.
But can we stop
the
this? Can we
swearing
stop
thing
this
is
idiot
just to stop people who are
twatting away?
triggered and angry.
So what you can do there, Sleeping Warrior, zoom out a little bit there. You zoom out one level.
Sorry, you want me to? Sorry, you're talking to me, epistemology.
We're talking to Riley. I keep looking. That's good. Go left. Pan all the way to the left.
That is the left.
Yeah, okay. Now pan to the right a little bit. Trying to see. Hold on. Stop. There's that.
I'm just checking that we've got the same information, that we're working on the same song sheet, and then I'll show you what happened as a result of the like overlay. Is this what you got?
Yours looks a little different. The one that was posted yesterday is the one that I was going off of, which is this link here. This was the one that you posted yesterday when I asked you to post it.
Do you see it in the group chat?
I put it in the group chat there. That was the one that I was going off of. I don't know if there was a corrected one from that point.
Right. All right.
How many do you have, Riley?
Pardon?
How many do you have?
Well, we've had 2 or 3. Ranty's put all these together, and as the conversation's gone on, they've just like literally zoomed in too much or not zoomed in far enough. I don't know. I can't really account for what he's done because I didn't do these myself. But
Are they
Right. So if this is different to the one that you
stop there. This is oh, it's just to the left of that. I think the duplication is very obvious.
Yeah, this one is actually different than the one that was posted yesterday.
Yes, actually. Sorry to interrupt. I keep on interrupting you, Pistol. I apologise. I think he knew that he'd made a cock up, because I saw that thing from this morning, and his image wasn't the same. I think he spotted that he'd made a cock up, and he actually fixed it in the Hangout. The image was different this morning, and I think he realised he made a cock up, and he's actually tried to fix it.
What's the effect of the cock?
Big shout out to Jermaine Williams for the super chat. Thank you very much.
Yeah, it adds a lot more land to the left of the image.
Yes, exactly. It adds a huge amount of land to the left, the original image, but I think he sort of fixed it from the image I saw from this morning's Hangout. So
all right.
I don't know that for a fact.
That would be consistent with what I understand it to be. I believe that he has fixed it since.
Right. Well, the image he showed yesterday was an absolute disaster. And that epistemology and I have both identified where it went wrong, and it's an absolute hash. And you claiming that Douglas is where it is, when in fact it's not. It's that place beginning with B. That's not Douglas. You identified so clearly and so adamantly yesterday. It's not.
Well, let me go through the thing that he sent me since yesterday. With regard,
it'd be nice to him to said that he'd fixed it and he realised he'd made a huge cock up. But oh no, we had to go and find out, and he disguised the fact that he'd cocked it up. Cheeky,
I think that's a bit harsh, to be honest, because it's a fluid thing and we are working on it.
Oh yeah, I don't deny that he didn't do it. I don't think he did it deliberately initially, but it'd be nice if in this morning's Hangout he'd said, "Oh dear, I made a mistake yesterday," and epistemology I could have been saved several, I don't know, whatever, how many minutes we spent on it, and then he could have said, "Yes, you shouldn't be using the information from yesterday." Meanwhile, epistemology I've been fixing the damn image to try and make it make sense.
Well, we've also been working on it too. It's not as if we know what we're doing here. We're working it out.
Well, we know that. Epistemology, I think, have determined that.
I think that we're working on it as we get criticisms and the fair position.
Well, to me, I spotted it within a few minutes of looking at it, and so did epistemology. It's just, to have pieced it together as he did suggests he put absolutely no effort initially into getting it right.
Well, I don't think that's a fair comment to make.
Well, the error is so gross. If you go and look at it, as I did, anybody, a 13-year-old, could have spotted the errors.
Okay, he made a mistake, and you've spent time on it, and I'll apologise on his behalf. I'm sure it wasn't intentional, and I don't think
I agree with you there. I agree there, but it'd be nice if he'd admitted to it. If he has fixed it this morning.
He's out with his girlfriend tonight, so until later on, so he's not going to be back for a while. But this is the way I understand it to be. I'm on the far right of the screen, and we can see. I'm focusing more on the contour of the land, because I don't think you'll be able to see the dots that are in the land, but we'll try it anyway. As you can see, the contour of the land pretty much matches precisely what we see in the image, and it gets down to this point here where it drops down, and then we have this point here where it drops down, and all these lights. I don't know if you can see these lights, but these white dots here. Ranty's picked out some of the ones that.
That's right. In fact, I know he's fixed it because those were the things that were duplicated. So those dots here were duplicated in the image he had yesterday, and they're not duplicated in this one. So therefore we can deduce that he has indeed fixed that.
Okay. We notice that there's a triangle patch here of dark land, and that looks like it matches perfectly there. And then we have these buildings that don't appear on here, but are probably in the right place. But for some reason, we can't see them. They might be in a ravine or something.
I think the reason those aren't there is because they're below that red line that Ranty showed, which should actually be obscured by the curvature of the Earth. That's probably why they're not showed on Google.
Well, I'll come to the red line one in a sec. As the land comes down from this point here, it drops down to another tuft of trees. And as you can see, it drops down here and it comes to another tuft of trees. So at this point, we think that we're matching. And then it comes down and it flattens out and then drops sharply there. And then it comes down and flattens out. And we think this drop sharply is the end of it. We think this bit here is the end. Might not be, but we think it might be. And then the rest of the land here, we think's island in the background. Now, Paul disagrees, obviously, but
you can't even see. You can't. Looking at my analysis, you can't even see the entirety of the Isle of Man, which makes sense because you can't see the southern lowlands, which is 50 miles away. Or you're claiming you can, but you really you can't. It's over the horizon because the northern lowlands, which is only 30 miles away, you clearly can't see the northern lowlands. Why would you be able to see the southern lowlands that are 20 miles further away? That makes no sense.
Well, that's because the vantage point, and that's because of the atmospheric conditions.
I've just remembered what this line is. This line here is that place called Douglas. When Ranty's put this line in,
yes, the place which you claim was Douglas to the right. Yes.
Yes. So look at the land that's here. We think this land here is.
My analysis, it's clear that Douglas is over the horizon.
No, it isn't clear that Douglas is over the horizon because what's this land that's here that seems to match up with this land here?
I think that there's another.
Well, when you say it's Douglas, it's where Douglas would be, but
It's
that's
so different. You see how different the contrast is between the two frames? That shows that it wasn't cropped well.
Say that again, epistemology.
Because this was from video, right? This isn't individual still frames, right?
Correct,
This was
from a video.
Video. So there's no reason why there should be this huge difference in the shade of the contrast between the two frames. The frames that are melded together better, there's a very, very slight difference in contrast as opposed to the
like that. You can see the seam where all the things have been joined up.
In some of them, it looks more seamless than in others. And the thing is, because this is now we're going off of different versions of this panorama that has been corrected. I'm not sure if there's still some duplicated landmass in there.
Well, you can have a copy of it if you'd like, and I'm sure if he's made any mistakes in this, you'll be very quick.
Yeah, put a link to this new one in the thingy, and then we can go and check it again.
The good thing was the one that he linked me, there was more land. It had like several copies of each frame. In other words, there was more land there. And so I was able to identify the points and actually line everything up to get a clean panorama.
Yeah, right. Some of them are truncated, some of them are overlapping. I mean, it's just the first one was such a mess.
All right, maybe it was a mess. And again, I'll apologize on his behalf. Okay.
But then of course, then you based your you deduced that was what you're looking at now was Douglas when it isn't as a result of that, and then you were saying, here we go, Douglas. So you make all sorts of deductions from this flawed information.
Right, Ranty spent 3 hours on this before the hangout this morning, and he's put this together since the hangout of last night. So again, I apologize for his mistake. Okay, let's move on from it. This is where we're currently at.
It's much improved. I agree with you there. It's much improved.
The land here matches the land that's there, and the land that's here matches that. So then when it drops down, it looks like that bit there is that bit, but we're losing a bit of the
Why are you putting up with this tosser? Can we check this guy?
Was that porn?
No, it's the guy. We gave him enough leeway. Anyway, we've got a new introduction. So, how you doing, part-time vegan? Good to have you here. Nice to see you.
Anybody hear me? Hello?
We can all hear you. Yeah.
Okay, cool.
Yeah, we can hear you.
All right, so we think that this tuft here represents these trees, and then we're beginning to lose like the proportionality. But as it comes down to this point here, we think that this point here represents this part here, but the land in the background is higher. So we're seeing this part here as this. And then basically this part here is where we now believe, or we now think is Douglas. And then we think that Douglas stops here.
Where did he base that white line that it's Douglas? Because on my thing, I actually drew a line in Google Earth to Douglas so that I could see where that ray goes. That way I could see that it was clearly not visible in my shot. It was over the horizon at that point. I had not enough land left in my picture to point it to Douglas.
That's exactly what he's done. He's used Google Earth to get to pinpoint where it is, and because he's over.
Epistemology is not saying that. It's not. You can't see the town of Douglas. That's just below that line, underneath the level of the water, is where Douglas would be. I think is all he's saying.
The problem is when you look in that direction of Douglas. Once there are some like 300-400 foot bluffs in front of just north of Douglas, but when you go south of that, it's all lowlands, which there's no way that's going to be visible.
I agree, but then we're still left with what's the land that's evidenced here that stops here?
No, that's where, this is Douglas. Hold on, it doesn't. No, that's Douglas, and you can see there's only a little bit left up to the left of Douglas. It's perfectly a part of the of Isle of Man. You can, on my image, it seemed to be perfectly agreement with the line you expect. Although obviously it's slightly lower, and it's an agreement for me anyway, from what I did. But I accept epistemologist's point about the fact if you can't see the northern lowlands, why should you be able to see the southern lowlands? But
yeah, the southern lowlands are 50% further away. I mean, the northern lowlands, which you can't see, are only 30 miles away. The southern lowlands are 50 miles away.
What's the height of the northern lowlands? Above sea level?
About 80 feet.
Yeah, because the southern ones that we think we can see are, was it 20 meters or something, 8 meters or 10 meters or something?
When you say the northern lowlands, do you mean this bit to the right of Ramsey?
Yeah, I think that's what epistemology means. Yes.
Well,
We're talking the area south of Douglas.
Well, this bit is 60, 80, 100, up to about here. This is the peak of the highest part is 260.
We can't see any of that in your video.
Yeah, but this isn't relevant though. This is
it's a bit odd though. That's a bit odd that we can't see any of that.
Yeah, it's 30 miles away. You can't see that land, but you're claiming. And why can't we see that land if the Earth is flat, right?
A little bit.
Because there is a little bit of obscurity on the horizon, and it is extremely low land, right?
Right, but why wouldn't it be obscuring the lowland south of Douglas?
Well, it probably is. That's why we think we're looking at Ireland.
Yeah, that's what they. Yeah, that's yes. Watch that episode. They're then going to claim that's Megan's they're looking at, but it's clearly not though.
Well, right. The fact that
in my analysis, you can't even see the whole aisle. You run out of land in the live picture.
Okay, well maybe I'm superseding your analysis right now, and maybe you could. I mean, I can send you this file and tell me where we're going wrong, but it would appear, as far as we can see, that these trees here match these, and then it comes down to this area that's somewhere down here, which is like Douglas, is around here somewhere. Exactly, don't know because it looks like it's changing its aspect ratio as it gets.
I think the problem here is I think that he's duplicating land masses again.
Okay, so I'll send you this file and show me where he's done it wrong, where he's got it wrong.
Go ahead and send me that. Just go ahead and add it the way you did yesterday and put it in the green, and I'll look at it.
All right, I'll do that right for you now. Remind me how to do this. I remember where to do. Hang on. It's Hangouts, isn't it? Hangouts.google.com. That one. This thing down here. Right, hang on.
Yep, perfect. Yep, exactly.
Now where's that file? Oh, I think it's here. Yeah, there it is.
While you're doing that, I just want to point something out that Ranty was desperately trying to say that you had been sharing the wrong photo, that it was the rough one he'd done first. He was saying it over and over in the chat at the end of the hangout last night.
He did tell me that, but I didn't want to over apologize, overcompensate for him. He was telling me I'd done it wrong. Has that gone? Oh, that's what I need to hit. Right, and then the second point I'd like to make while you guys are getting that and considering it, Ranty has since put in a line to represent where the curvature is, because it was clear that Lewis didn't understand what the curvature numbers meant. So what he's done is he's put a line in it to show where the curvature is meant to be. And I'll just show this.
I didn't understand what you said then at all. That last sentence didn't make any sense.
It will in about 30 seconds.
Pardon? What was that, about 30 seconds?
What you just said will make total sense with the next image. I only know this because I've already seen it.
Yeah, I think it's not that one. Lewis seemed to be struggling with what the curve calculator meant when it said refracted hidden. He was arguing that we can't see down to the beach. And then the reality, it's obviously in that one. Let me go back to it. Just bear with me while I find it. I've got about 4 or 5 conversations going on. That one. Right. Lewis was arguing that it can't be flat because we can't see down to the beach level. And what Ranty did was he put in where the curve is meant to be. And this isn't accurate for this part at the beginning. This is accurate for the part at the end. Because obviously if it's a curve, it gradually gets worse as you go along. So a straight line's not going to work on a curve. But this is all meant to be behind the curve according to what Ranty calculates. None of this is supposed to be visible. And this represents...
That's correct, yes. And this is... We're going to come on to this. This is the final issue. Which is refraction, and your lack of understanding of what non-standard refraction is.
Well, let's go back to the basics with this. Not the basics. Let's go back to the science because thankfully I do have some background on the refraction point. I mean, I'm sure you're all aware that I had the debate with Mick West, and in the debate that I had with him, in the back and forth, Mick recommends strongly. He highly recommends this particular paper for the effects of refraction.
It's a good paper. Yes, it's a very good paper.
It is a very good paper. I agree. It's from MIT. It's considered to be credible. It's supposed to be a good piece of paper.
It is.
And when you go into this and you actually read it, which I did, I read this several times. It talks about under standard circumstances, the effects are negligible. And I'm asserting that this is clearly standard effects because
hold on. How are you asserting that? What you do? See, this is what you don't understand. You see, this is what you claimed you made yesterday.
I don't understand.
Right, I will explain to you what you don't understand. You see, someone mentioned non-standard refraction, and what you understand that to mean is the Fatiga-Mongani. What you don't understand that everything this 7/6. Why am someone echoing me?
I don't know. I think it could be Anthony. I think we're getting an echo from you, Anthony.
Oh,
Right.
hang on. Let me just make sure.
Right. This.
Is that any better?
Yes, that's much better. Yes, what Mick West has done in the
Big shout out to Peanuts Clark for the super chat. Thank you very much.
What Mick West has done in that calculator is included that 7/6 correction for refraction. But this is just something that what surveyors do when they're looking over, say, a period of 200 or 300 meters. They insert that 7/6 correction. It's called just the standard correction. But in the circumstances that we're dealing with here, over 50 miles, that's irrelevant. It's not a standard thing you can use over 50 miles. It just happens to be something they've picked for something that works over 300 meters. And
so let me give. Let me read what it says from that.
I know you're going to show me these weird examples of mirages, but what you don't understand is what is non-standard is anything that's not the 7/6, which can include less dramatic effects than the ones you're about to show. And in fact, I can show you this. I've got an example.
So that by your definition means that we would never be able to prove flat no matter what, because if it wasn't standard, it would revert automatically to non-standard, and therefore you claim the victory, regardless of how flat it appears to be.
Standard just means that it complies with the 7/6 correction. Anything else is non-standard. That can be 10/6, 20/6, or it can be inverted to the point that it's negative, like you're showing with the these images you're showing with the inverted mirages.
I repeat my words. If that's the case, then it would mean that no matter what evidence you get presented with, you will never accept it, because you will simply argue that it's non-standard refraction because it appears to be flat.
Well, nonetheless, I'm about to show you. I can show you a lovely image I've got here.
Hang on. Before you do that, let me finish my point.
Okay.
It says it is under non-standard circumstances where we really see some amazing. That's a key word here.
Yeah, but also, but what you don't. This is it. You don't seem to understand English. But also under non-standard circumstances, it might be very slightly different.
I don't seem to understand English.
Yes, because let me explain why. Because amazing is a subset of non-standard, but that doesn't mean to say that non-standard is amazing. You don't seem to understand that non-standard is an umbrella term of which amazing a small part. It's like saying the globe, of which, say, Britain is a small part. But that doesn't mean to say that Britain is the same as the globe. You don't seem to understand a tree hierarchy of the definition of non-standard and amazing. Amazing is part of non-standard, but that doesn't mean to say that amazing is non-standard.
I'm 37 years old. I'm quite well educated to a high degree. I understand what the word amazing means. If we need a dictionary definition,
do you understand amazing is a subset? Do you understand the concept of a subset?
Yes, I do, but it doesn't use a subset
of non-standard. That doesn't mean to say that everything is non-standard.
Big shout out to Daylight Ohio for the super chat. Thank you very much.
If you look in the text, all it's saying is that if it's amazing, it also has to be non-standard. But that does not imply that non-standard is amazing. Can't you see?
Right, let's go back to what it actually says, and we'll just apply the normal meaning of the words. We're not going to change the meanings of words.
Exactly.
We'll apply what it says.
Read it in context of the entirety of the paper.
Yes, we'll read it in the context of the entirety of the paper.
But can't you see from just an English point of view what I've explained to you, that amazing is a subset of non-standard?
So you say
non-standard is not
I'm saying it does not taking this out of context and changing the meaning of the word.
Oh, no, it's not. I'm not. You're not understanding the idea of a subset, are you?
I completely understand what you're saying, and I disagree with you because it's not in the context in which it's written. Let's carry on.
Okay, listen. We'll just leave it. It says it is under non-standard circumstances when we really see some amazing max. In other words.
But wait. It's the next line that's important. Probably the best known is the inferior mirage, which occurs when lower regions of the atmosphere are much hotter than higher regions, as in deserts. Yes. So the index of refraction is an inverse function of temperature.
What it's saying there is that when it's amazing, it's non-standard. Of course, that's the case. But that doesn't mean to say when it's non-standard, it is amazing. You can have a slightly non-standard situation, or a slightly more non-standard situation, or a slightly more non-standard situation, until eventually it becomes so non-standard, you get these sorts of images. I mean,
it has to be. Here. It has to be amazing for it to be non-standard.
No, it doesn't. Non-standard just means it's not 7/6. No, hold on. This is the key thing. Non-standard simply means it does not comply with the 7/6 correction. So when Nathan goes on about, oh, look, we've corrected for refraction, all it means is that Mick West's refraction calculator used 7/6, but that's a standard correction. An 8/6 would be a non-standard correction, but still perfectly possible. It's just they picked on the term of 7/6 to be standard, but it could be 7.1/6, and that would be non-standard. It could be a very slightly different from 7/6, and it would be non-standard. You don't seem to understand there's a graduation from standard to amazing, and in halfway between those two is quite non-standard. Then there's very non-standard. There's incredibly non-standard, and then there's amazing.
So that means, again, I repeat my words for a third time, that means no matter what evidence you get presented, you will simply argue that it's non-standard refraction and therefore it's still a curve.
Yes.
Right. How dishonest is that?
Well, no, it's not, because that's reality. We work with reality. Well, I can show you. I've got an image here that will show you what I'm talking about.
Hang on. If you've just asserted the position that you will always adopt the non-standard, why are you even in the debate?
Well, no. Well, because it's reality is like saying 1 + 1 = 2. If the circumstances, with these circumstances we're picking on here, we're 50 miles away and we're looking through water, looking through a layer of air that is incredibly narrow. And do you know what the error has to be in the refraction? Do you know what tiny little angle would have to occur to account for the errors we're getting? It's absolutely minuscule. But over 50 miles. It causes an effect of 200 meters.
Sorry, can I just ask the Rumpus a question? Sorry to interrupt you, Anthony. I just want to ask Rumpus a very quick question. So, is your position that what we are seeing here is a mirage?
It's called looming, and I will demonstrate. I've got a fantastic image. I mean, this is I don't know why you're laughing. This is well-established facts. And I can show you an image here that will demonstrate this exactly, which I was trying to prepare, but I didn't have time to.
But what we're seeing is actually behind the curvature. It's being brought back by refraction, is what you're saying, correct?
And I will demonstrate, and I will show you how this happens in a fantastic image I've got. Let me just go and get it.
So we're not really seeing it. It's just an illusion.
Take your time.
It's not really. We're not really seeing it. It's an illusion, correct?
It's called looming. I don't know if you're familiar with that term.
Sorry, are we directly seeing the item that we're looking at or not? Is what I'm kind of asking.
Yes, of course. There's the light, but it's not the light coming to you is not following a straight line. It's being bent.
Right, but we can demonstrate what bendy light does.
Okay, and here
it doesn't bend it from behind a curve that doesn't exist.
Hold on, let me just show you.
I'll tell you what. Whilst you're getting that, let me show a very quick counter, because I know what you.
I've nearly got the image ready, actually.
That's okay. Well, whilst you're getting your thing,
okay,
I'm going to ask you to contrast a well-known atmospheric effect that we call refraction to what you're talking about, because this is refraction over a long period of time, over a day. And I'm going to ask you to distinguish what you're talking about looming-wise, because I'm going to assert that you've got no evidence to prove that it can happen.
What's happening here? This video you're showing is demonstrating various levels of refraction.
Correct. And I want you to distinguish how.
So these are all non-standard. So hold on. This is examples here of non-standard refraction, because
this is just refraction. This is all it is.
But it's non-standard because it's changing. It's changing over time. Therefore, it's non-standard. It's not staying constant.
But
most of these images you're looking at are using the non-standard refraction.
But notice how the Isle of Man or island in the background isn't dropping behind the curve and coming back up, and that's what you're going to have to argue and present evidence to prove can happen.
Well,
so as long as you can prove causation, you can have.
Well, this is the thing about atmospheric conditions. I mean, obviously, it's more. We're dealing here close to us. Possibly, the water is warmer than it is in the distance, and we're not looking through it. But what you should understand is, from those images you were looking at, you were seeing non-standard refraction because it was changing. The standard refraction model used in the Mick West thing is 7/6. It was changing in the image you were showing. Therefore, most of the image you were looking at was occurring in non-standard refraction cases.
Yeah, but you do realise that the 7/6 radius is a calculation geometrically rather than a calculation based on pressure, density, vapor.
But it's a typical. That's why it's a standard. You see, what they've done is they've said what happens with the standard temperature and pressure in surveyors, because this is what surveyors use to correct for it. And they say, well, typically during the day,
I can take that one. I can take that one to show that Anthony is absolutely incorrect about that.
Well, you've had 2 goes, Paul. Let Rompus have a go. You've had 2 goes and not been successful so far. Let Rompus show us this theory, and then I'll ask him for his evidence. And
you're absolutely incorrect about that, Anthony. Absolute load of rubbish.
Well, I'll make way for Paul. I mean, I've been speaking quite a lot recently.
Yeah, can I just have the floor for a few minutes to show that Anthony is absolutely wrong about this? Okay. What's shared on my screen?
Well, while they argue the toss about that, I'm going to do a couple of links as we are coming up on 1 hour. If you are new to this channel or you have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with these flat earth debates. If you would like to support this channel, then hit the super chat as several people have already done. And most importantly, if you would like to join the debate, there is a link in the info box below this video. With the page you are currently listening to on mute, simply click that link to join the discussion and express your views on the shape of the earth. There are a couple of rules in the Hangout. Number 1, please do not swear. If you do, you'll be ejected. And if you are, please do not try to rejoin the stream using sock accounts. You'll be warmly welcome back on the next stream. Please share the show on social media as it increases the live audience, which in turn increases the diversity of the panel. One more time, if you're new to the channel or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth debate.
If you put standard atmospheric conditions into this, you get a value of K that when you plug it into this formula gives you your 7 on 6R.
Correct. Absolutely. And what you don't understand,
and this shows clearly that the K depends on pressure, temperature, and temperature gradient.
Yeah, and the point is, you keep on claiming it's just geometric. It just so happens that the maths comes out such that you can make a correction to the radius. It just so happens that the maths comes in that form. So I know it's geometric, but the point is, it's conveniently, it means you effectively, it becomes a difference in the radius. It just so happens that's how the maths turns out.
Okay,
so
let me
going on about the fact it's just geometric. I'm afraid it's not. It's just it comes out as dimensions of length, which affects the radius, but it's based on the pressure and temperature as described by Paul there.
Let me respond, because you've had a chance to make 2 points there.
Yeah, go on,
Two people made 2 points, and I'd like to respond without being interrupted, and then you can respond back. Okay.
Before you do, I'm going to introduce Tony. So, how you doing, Tony? Good to have you, Tony. Nice to see you.
Hey, what's up, Nathan?
Good to have you.
What's up, guys? Keep going.
Sorry, you go ahead, Anthony.
All right. So it says, according to this bit, it says standard refraction is calculated on the radius. However, underneath it says it's an approximation of the refraction expected under the standard atmospheric conditions. When we go into this, it takes account for pressure, temperature, density, and viscosity of the Earth's atmosphere. But here's the thing. If radius was anything to do with it whatsoever, when it comes to this particular equation, and it reads from it verbatim, it says the model divides the atmosphere into layers with an assumed linear distribution of absolute temperature, that's one element, against geopotential altitude, that's a second. And then it says for the other two, the other values, pressure and density, of which we know that they vary throughout the day. Minuscule, but they vary up and down throughout the day.
Anthony, what you don't understand is all that formula that.
Hang on.
Very quickly help you here.
No. I don't want you to very quickly help me. I want you to listen.
Oh, yeah, but I understand exactly what you're saying. You're saying.
No, hang on. You don't, because I haven't said it yet. Just wait.
Okay.
Because it says the other two values, pressure and density, are computed by simultaneously solving the equations. So you've got to simultaneously solve the vertical pressure variation and the ideal gas law. So this simultaneous solving of these equations is what gives you this.
Right, but what you don't understand is this 7/6 is just an approximation. It's something that surveyors use, as I say. Well, I know what we're taking average for the conditions that using the formula that Paul suggested to you.
I understand what you're saying.
So they're saying, right, well, let's just take some typical examples of temperature, pressure, gradient. We're going to use this when we do surveying over a few hundred meters, we'll use this as a typical situation. Most of the time, it's not going to be that. But just as a random average, because you've got to pick on some value, otherwise you're not making any correction at all. So they pick on a particular value, which is based on the formula that Paul showed you. They shove it into odds, and it just so happens that it pops out as changing effectively, not actually, of course, changing the radius, but it means you can just correct. You can do a simple correction in the formula by just shoving in a slightly increased radius. It just so happens that's how the maths works. It's not changing the radius of the Earth or anything. It just so happens that all the results come in as a particular added dimension you can multiply the radius by. That's all that's happening.
Right, just shut up a minute, because I haven't finished my point and I'm still not got to it. So I want you to just let me finish my point.
Okay.
You can see that these values are going up as well as down. They're not only going down.
Correct.
Agreed?
Yep.
So when we come out of it and we go back to the maths, the vertical pressure and the gas is going to be the variable that makes it go up and down.
Yep.
The problem is, if we're only accounting for the radius of the Earth and it's 7/6, this is a calculation that only ever goes down, never up.
Oh my God! You just not listened to a word I said, have you? That 7/6 just is the pops out of that formula that Paul showed you, and it goes up and down. You can do anything it likes. The 7/6 just happens to be one they've picked for a standard condition.
Can you demonstrate using that standard refraction calculation any occasion where it goes up?
Well, the 7/6 can be smaller or it can be bigger. He's just picked 7/6 because that's what everybody picks as a standard correction. But it's not valid in extreme situations. It could be 10/6. It could be 3/6. It varies. Everybody agrees.
Guys, listen. Can you illustrate?
The 7/6 was the result of implementing that information.
That's right. 7/6 is a result of that formula.
It's not a guess. It's not something somebody pulled out of their butt. They didn't vote on it.
Can you demonstrate 7/6 of the radius ever going up, please?
What do you mean?
But the value of 7/6 is not constant. Anthony, listen, that 7/6 will have value they picked. It could be 5/6. It could be 3/6. He's just picked 7/6 because everybody agrees they've got to make some sort of correction. And typically, on a typical day over 200 meters, surveyors have agreed that 7/6 is the result of the output of that formula. But in another, when it's a hotter day or a cooler day, 7/6 is wrong. It could be 5/6 would be the correct value to stick in that.
But that would still be going down, wouldn't it?
Well, 7/6 is greater than 1. If it was 5/6, it'd be less than 1, in which case you could be going the opposite way.
Right. So where does the math account for that? How does the
formula that Paul showed you determines the value of 7/6. The 7/6 is a variable. It's not a constant. That 7/6
but it's a down.
Not a constant.
It's a down all the time. It's never an up.
It's not. No, it could be. 7/6 is bigger than. You agree that 7/6 is bigger than 1.
Right. Can you
now that formula that Paul showed you come up with 5/6. It could be less.
Rompus.
Can
you demonstrate mathematically or evidentially 7/6 radius going up at any point, please?
What does that mean?
It's not 7/6. It's not a constant. He's written 7/6 as the result of a formula. It could have been 5/6. In which case,
so how does your maths account for the variables that go up as well as down?
Because the formula Paul showed you can be greater than 1 or it could be less than 1.
But it's always going down, Rompus. That's the problem.
No.
What is going down? You have to speak his language. Nothing is being communicated here.
Whatever value you put in for the refraction adjustment is always a reduction. It's never an improvement.
Because the correction you've got there is 7/6, but that's wrong. Oh, that only works.
I agree it's wrong.
Right, it could be 5/6, in which case that would account for it going down, wouldn't it?
Yes, but I'm asking you to account for when it goes up.
Okay, that's when you make it smaller than 1. If it's 5/6, that would account for it going up, and if it's 7/6, it goes down. So
that's not what the math says, though, Rompus. It says 7/6.
7/6 is just over 1. Imagine that 7/6 you're looking at now read 5/6.
Yeah, but then you're not applying your own maths, and you can't make stuff up.
Okay, stop my jump in and answer now.
So basically,
time I jump in and answer. Explain to Anthony when it goes up and when it goes down according to the formula.
I'm going to share my screen. It never goes up according to your formula.
It does, because 7/6 becomes less than 1.
Right. It never goes up.
Can you share my screen?
It never goes down.
Do you agree that 5/6 is less than 7/6? If you agree that you can have a value less than 7/6, you agree it goes up.
We'll demonstrate it.
It's not a constant. You seem to think that 7/6 is engraved in stone. It's not. It's a variable. It's a variable.
Okay, sorry to turn you guys down, but we have been joined by a new guest. So how you doing, Chris? Good to have you here. Nice to see you.
Oh, how you doing? Thought I would jump on.
Very pleased to have you, Chris.
Can you share my screen, please? And I'll do some calculations on screen for you.
Guys,
there's a couple of things I need to point out here. Yeah, hi, Chris.
I just need to hear him speak uninterrupted. How you doing, Chris?
Yeah.
Thanks.
Perfect. Thank you.
And I just wondered that you're flat earth yourself, Nathan.
Got a terrible connection.
Yeah, you're buzzing.
Can you hear me now? Is that better?
No,
not really. It's not.
Left side.
I think it'll come back in. Right, so let's demonstrate how this never accounts for up. Okay, so we've got a viewer height.
You said you're educated.
Stop it, Anthony.
No, I'm using your maths and your model, guys.
Show him, Paul. Go.
All right,
Yep,
you show
absolutely.
me. You show me how
Okay.
7.6R becomes up at any point.
Because it's not 7 out of 6 is not a constant. It's a variable.
It is a constant.
Sorry.
It is a constant.
No, because the 7 out of 6 is the result of this calculation. It could be 5 out of 6 could be the result. The 7 out of 6 is not a fixed value.
Let me show you how that's wrong.
Big shout out to Daylight Ohio in the super chat. Thank you very much.
Listen to me.
Yeah,
no,
listen to Paul. Listen to
this
Paul.
is your model. This is your maths.
Yeah, exactly. So try and understand it.
Like it.
Stop and listen. I'm trying to explain it to you. You asked me to explain. Now have the courtesy to listen.
Well, actually, I didn't ask you to explain, but go on. You can do now.
I'm okay now. Can you guys hear me now?
Terrible.
No, you sound like you're drowning, mate.
Fuck's
God's sake.
Go ahead, Paul. Come on, get this out.
All right. Thank you. Okay. You can clearly see that the formula has values of P and T in here, which will always be positive. You can't have negative temperatures under normal conditions.
No, but you can have continuous
pressure.
variable pressures.
Yeah, well, hold on. He's about to demonstrate how to change his sign.
Let me explain.
Let Paul get to the end of his point.
Here, do you understand what this part here means, Anthony? What this quantity here is?
Paul, it looks just like
I need
maths.
to know that you understand what it is.
It looks just like maths. Talk me through it, Paul. I've never seen it before, so talk me through it.
Okay. What this is what they call a rate of change. It's the rate of change with temperature with height. It's called the temperature gradient. You take a temperature difference and you divide it by a height, and you get a rate of change of temperature with height. Now, if you have a cold body of water, then the air above that water is going to be cold, and it will gradually increase in temperature as you rise up. The temperature gradient will be positive in that situation. You will have a positive temperature gradient, and it will add to this quantity here.
Yeah.
However, under standard atmospheric conditions, like normal, when we're looking at stable air in a city or something like that, where surveyors use it,
curved?
The temperature gradient, let me finish, please. The temperature gradient as we rise up in the atmosphere well above a body of water decreases as we rise in altitude. It becomes a negative temperature gradient. And so this quantity here becomes negative.
Well, how is that related?
And so it subtracts from this number.
He's about to explain.
Okay? So I have just shown you where sometimes this temperature gradient is positive, sometimes this temperature gradient is negative.
Okay,
and that changes
I accept that.
what happens in this formula.
I accept that, Paul.
I can even go in now.
Right,
hang on.
Paul,
yes,
Paul,
I can
explain
do
what that does to the effective
for you now.
Paul, explain what happens to the effective radius, the fact that it gets bigger and smaller depending on the value of K.
No, I understand that, but that's
right.
not the maths of your model.
It is, because that effective, that R, that is 7 over 6. You see where it says RF? That is equal to 7 over 6. That's where the 7 out of 6 comes from. It's that R effect. And that could be bigger than 1 or less than 1, depending on the value of K.
You're moving the goalposts, Paul. That's not what your model says mathematically.
It is. It's exactly
what moving. Yes, this is the mathematics. This is the mathematics.
Your
we can plug in.
7.6R.
I will actually do the calculation right now.
No, you don't
show
plug
you
in
where
the 7. You're doing it again, Anthony. You don't plug in the 7. The 7 out of 6 is the thing you multiply what the 1 minus K is. The 1 minus K becomes 1 over 7 over 6.
Here, Anthony.
It's not your
that
maths,
bit down
Paul.
there is what
That's a completely different set of maths. And I happen to
You
agree with
obviously
that
just
maths,
don't
Paul.
understand it.
Paul, I happen to
Let
agree
me do
with
a
that
calculation.
maths. Listen, I
will show you.
Paul, I agree with that maths, but that's not the maths for your model.
It is. It is.
It is.
It isn't.
Who are you to say this is not the maths for our model?
I'm applying your
This
maths,
is
Paul.
the maths.
That's not the same set of maths.
You're not understanding. You're not understanding.
I don't agree with the 7.6R maths, which your model is based on.
No, it's not based on the 7. The 7 of 6 comes out of this equation. It doesn't go into it. It's not an input value. It's an output value.
But your maths is...
Dude, I could...
Am I any better now?
No, you're terrible.
I think Sleepy Roy's been booted from the call, so I may bring him back in.
Right. Under standard atmospheric conditions, the atmosphere cools at a rate of 0 0.0065 degrees per meter as we rise in altitude. Okay, so there's that part of the calculation. Now we have to multiply it by standard atmospheric pressure, which is around about 1,030 millibars. Let's put in real numbers here. Then we need to divide that by standard atmospheric temperature. 20 degrees Celsius is 293 degrees Kelvin. So we'll divide it by 293 degrees. Then we have to divide it by 293 degrees again, because it's T squared. Okay?
Paul?
And then we have to multiply it by 503. And guess
Paul?
what? What number do we get out of that? The number we get out of that is 0.167. Now, what does that number represent, you ask? That number represents about 1/6. Okay? If I do 1 divided by 6, I'm going to do that. Now, you remember this number, 0.16777. I'm going to now do 1 divided by 6. 1 divided by 6 is 0.1666. How close is that to an extra sixth?
That's fine, Paul, but you know what?
Perfect.
That's where it comes from.
That value, of course, goes into this equation you've got just below. The RF is equal to R1
That's
minus
right.
1 minus. So 1 minus a sixth gives you 5/6, which gives you 7. Oh, whatever it is, 1/7. Then in that flip, then becomes the 7/6. So the 7/6 comes out of this equation. It doesn't go in. You seem to think there's some concrete constant stuck. It's not. It's a variable that comes out of this formula.
Right, Paul, I agree with the maths demonstration that you've just demonstrated, because as the pressure and the temperature vary throughout the day, you are going to get a fluctuation. Yes, I agree. However, that is not what your standard refraction maths is based on. Your standard refraction maths is based on a fixed sum.
How do you claim? So what do you claim? Hold on, Anthony. Where are you claiming it's coming from? Then it's coming. We're saying it's coming from this. Where are you saying it's coming from?
I'm not saying it's coming from anywhere. I'm just using your model to try and work out standard refraction.
So shut up, and we're telling you where it's coming from. It's coming from here.
No, that isn't where it's coming from. You're telling me somewhere it comes from that I agree with, but is not your citation. I'd like your citation for the standard refraction, please. Though your model.
Is this any better?
Yes.
Yes, that's a lot better.
Right. Okay, cool.
I mean, an 11-year-old would understand this, Anthony. The 7 out of
you're right.
over
An 11-year-old can understand this. It's black and white. Your standard refraction calculator is a simple formula. It's a fixed formula.
1 over 1 minus k.
It doesn't account for variations that go positively up. It only accounts for ones that are going down.
He's explained to you the sign can change.
And I agree with the maths that he's just presented, but that's not the maths for your model.
A larger value or a smaller value.
It's not your maths for your model. I agree with the maths he's just presented. I disagree that it applies on your standard refraction calculator. It clearly doesn't.
Big shout out to Earth Flattener. Thank you very much for the super chat.
This is the biggest display of ignorance I've ever seen.
It's just
no. This is the biggest display of moving the goalposts.
An 11-year-old can understand what you're saying.
Oh, he's gone up by 2 years now, has he?
Riley, I agree. No, that's not how it works. That's what you do, Anthony. And why wouldn't you debate Aaron Rye earlier on?
What's this got to do with the price of fish?
Just wondering, just while he's here.
Right.
I went into the hangout. I waited for 4 or 5 minutes and I never got spoke to, and I was busy doing something at the time, and I made my apologies and excuses and left. I did what you asked me to do.
Cool.
Back to the point.
Demonstrate where this 7/6 comes from, because you don't seem to understand.
No, I understand clearly. It's not that difficult. A 7-year-old can understand it.
Here. Right, am I screen sharing this? Can you see that?
Yep.
Right.
Yeah. Again, no, that's not your maths.
So where this 7/6 comes from when Paul did that calculation to deserve it, the factor 7 out of 6 you'll find is equal to when 1 divided by 1 minus k, when the value he gave you of k of being 1/6. So he said k was equal to 1/6. And so when you say 1 over 1 minus a sixth, I think that was right. No, so 7th, I think actually it'd have to be, wouldn't it? Oh God.
No, you need to put a 6th in there. 1 divided by 6. 1 minus 1 divided by 6.
1 minus.
Feels like we're watching Miles Davis trying to apply the
1 divided by 6.
Is that right?
Yes, that's right.
Yeah,
yes.
Sorry, right. So there you go. And that, I won't bother again. That pops out to be the value 7 out of 6. And then, so when you multiply, then you take that value and you do what in the first equation I've got here, which is that one. You then say, aha, right. So the value that so you then replace the 1 over 1 minus k with 7 out of 6, and so you end up with r.
You've got it slightly wrong still.
Sorry,
that minus in there should be a plus.
Oh, that one there.
Okay.
That one there.
Yes, that should be a plus. Yep.
Okay, yeah. Let's make that correct. This. So what effectively happens is you then end up with 7 over 6 times r. So the factor, the 1 over 1 minus k becomes 7 over 6. Now, if the k becomes positive, this 7 over 6 becomes less than 1. When the k is positive, it becomes 7 over 6. When it becomes bigger, or becomes positive, this becomes less than 1. So this value of 7 out of 6 is simply the result of this value here. It's that k, Paul showed you how that was derived, and this 7 out of 6 is a product, it's a result of that calculation. And it's just the one that everybody picks on when they pick on a particular gradient and a particular pressure and a particular temperature. They say, well, okay, these are what we're going to take as standard conditions for when I'm working on a surveying task on a typical day. We feed those numbers in. It just so happens the k comes out as being a sixth, and therefore the thing you multiply the radius by is 7 over 6. So this could be more than 1, less than 1. It could make the radius bigger or smaller, which would mean the effective radius would become bigger or smaller. So it can increase what you can see or reduce it. It can do both things because this value can be more than 1 or less than 1.
If 7 over 6 was all able to account for, allow, and calculate for the variation that goes up, then it wouldn't be a 7 over 6 radius, 7 over 6 calculation, would it?
It varies in value. I'm picking on it.
It would be the maths.
5 over 6, and therefore it would change the radius the other way. It would invert it.
You're moving the goalposts again. You're changing the maths to suit your premise. The point is, 7 over 6r as a mathematical calculation does not allow for a variation where there is a positive to it. In other words, it goes up. It only ever goes down.
No, he's demonstrated it could change in sign. K can change in sign, so it can go up or down.
If you want to try and persuade people that the maths is something other than what the standard refraction calculator tells you it is, be my guest.
All
you're doing is showing your dishonesty.
On a typical value of K. So K, it gets the value of 7 over 6 from the value of K. K can be positive or negative, which means that the 7 over 6 can be bigger than 1 because it's 7 over 6 is just more than 1, or it could be less than 1, so it can go up or down. This is not fixed in stone.
It can only ever go down.
On the value of K.
If you want to believe that, dude, you believe that. But your maths, your model doesn't allow for that because it's a fixed formula.
You've been shown the formula. I mean, I'm talking basic maths.
I've been shown a different formula to what's cited on the refraction calculator.
The refraction calculator is just picking on a particular value of K in effect. Everybody picks on a particular value so they can stick in a correction.
That's the problem. That picking on a particular value of K doesn't allow for it when K goes up.
It's not fixed in stone. If
it is,
looking at
7/6R is fixed in stone.
Real value of K is, you need to plug in the values for pressure, temperature, and temperature gradient, Anthony.
No, you don't. You
Anthony
just plug in 7/6R.
For us, like on pen and paper right now. Show us that he knows how to do it. That's just my idea.
I mean, you're being absolutely retarded here, Anthony. I mean, you're just demonstrating you have no understanding of anything.
I'm just applying your maths, dude, and your maths is not what you've just presented.
My math. Do you understand?
Let's go
very
simple.
Do you understand this
7 over 6R
varies? It can vary during the day. It can vary in conditions. Do you understand this is a variable dependent on the formula that Paul presented to you? So this can be positive or negative. Do you understand that?
But do you understand that that's not your maths? You are making your maths into something that it isn't.
Paul and I agree it's our maths. How can you tell us it's not our maths? We're saying it's our maths. Don't tell us it's not our maths.
Because it isn't your sum. It's not your sum.
It's not.
Remember what he's doing, Rumpus. Remember why he's doing this.
It's not. What do you mean?
Not your sum is simple. 7/6R is your sum. That's it.
But can't you see that pops out? For goodness sakes. This is amazing, isn't it? Do you understand?
Yeah, it's amazing.
Look, if I value if K was a slightly different value, this would not be 7 out of 6. It could be 7 out of 5.
But then it wouldn't conform to your maths on the standard refraction model cited by Mick West on the Metabunk site, because that's clearly 7/6R.
Yes, but it's the standard one. But he would accept that if the pressure was not in the standard, if K was a different value because of different pressures or temperatures, that value would be wrong. It's just something they pick because they've got to pick a number, a typical number for a typical day. But if in different conditions,
because
he
it
would
contradicts your argument.
well, okay, if you want to give me the values of the pressure, the temperature, and the gradient, I'll change the number to be whatever the value of K says it should be. I mean, don't you understand the idea of an input to equation and an output of equation? The 7/6 is the output of a formula. The K is the input value, and the K is affected by pressure, temperature, and temperature gradient. So
all you're doing is compensating for why your equation doesn't allow for up, and you're trying to make people believe it does something that it doesn't. But any 5-year-old can work out that 7/6R is a continuous downward spiral. It is not going up at any point.
My God, this is just unbelievable. How
it is unbelievable. I'm just wondering how long you're going to keep labouring your point and making yourself look daft.
Anthony, in some years' time, you're going to look back on this and you're going to think I was a complete pillock. Everybody else in this panel seems to understand that the 7/6 is an output value of this formula, and that K is determined by the formula that Paul showed you. So this varies.
Let's test that. Let's test that. Let's check everyone on the panel and see, does what you're saying equal 7/6R?
We've been joined by Ali B. Good to have you, Ali. Can you hear us, Ali?
People in the chat thinking you haven't got the understanding of a 13-year-old.
Bear with this, Rumpus. Just trying to see if we can hear Ali. Bear with me. Can you hear us, Ali?
Ali's been here. Then Al-K just joined.
Hold on.
Is Anthony the only person on the planet who doesn't understand the idea of feeding in some numbers into a formula and then out pops a different number, and then you use that number inside another formula? I mean, this is just extraordinary.
Maybe you're the only two people that move the goalposts and claim something that they're not.
I mean, if we can't talk to you in simple mathematical terms of a function in which you feed in a number and you get out another number, and you don't understand that 7/6 is a
I'm asking you not to change the
formula.
model that your maths is based on. Stop changing the rules.
I don't understand what you don't understand. Paul showed
me
you're
applying maths that your model doesn't account for.
Paul, I mean, Anthony, this is just ridiculous. You're either really, honestly, you're either mentally retarded here or something's going on that's really weird. Paul showed you a formula.
The weird thing that's going on is that you're not doing what your model tells you to do.
And then gives you a value that you then stick into becomes 7/6. What don't you understand about that?
That you're not applying what your model tells you to apply.
Do you understand that formula that Paul? Do you understand the formula?
In what aspect? In what aspect?
Right in front of you that showed you the extra 1/6.
Paul,
I did a calculation, Anthony, right in front of your eyes that showed you where that extra 1/6 comes from.
Paul, I agreed when you showed me the more complicated maths that is the equation. However, I disagree that the 7/6R is the same. It isn't.
It is, because 7/6 is the value that pops out.
Let me put it to you in the
7/6 that I got out of that.
Right, let me put it to you in a different way. 7/6R is a continuous arc down. It's the same way that I put it before, but I'm trying to do it in a different way, and I can't do it any other way. Whereas the
7/6 is not fixed. It could be 5/6. The 7/6 is not a
it's
constant.
always going down. Now the problem is the maths that Paul showed before are a continuous variable that roughly hover around the same value, up a bit, down a bit, always about the same. That's not a continuous going down.
They do not. They do not hover at the same variable. They are quite variable. And the one thing in that equation that is the most variable is the thing that matters the most, the temperature gradient, which can be either positive or negative.
But the thing is, Paul, every day the temperature starts cold, it goes warm, then it goes cold again, And if we apply your arc mathematics over the whole day, it's going to always go down.
No, because it can be positive and negative.
How can it be pulled back up?
Can I interject a second?
Absolutely nonsense. Of course it can. As the temperature gradient changes in nature, the refraction can change.
Go on,
sometimes the temperature gradient is positive, sometimes the temperature gradient is negative.
If you say so, guys, but everybody in chat can see that you're applying 2 sets of maths, and there's only 1 set of maths on the table.
You're amazing.
My God.
You're
These two are professionals. These two do this as their job.
You really do deserve the title of dumb of the year. I mean, you're really demonstrating extraordinary stupidity here.
Well, if you guys think that you can wrap something up in blue wrapping paper and tell me it's red, then yeah, be my guest. I don't mind being stupid, but everybody in the chat can see that you guys are changing the goalposts and applying rules that don't exist.
No, we're not.
Your rule is 7/6R. It's continuous going down. It's that simple.
My God.
No
Unbelievable.
goalpost changing here. You put the numbers into the equation, out comes the correct value.
We have approximately 30 minutes left on this live stream, so I'm going to run through a few links. If you are new to this channel, or you have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth debate. If you would like to support this channel, as many have done already on this live stream, thank you very much to all the people who hit the super chat. Hit that super chat that runs alongside the show while it is live, and most importantly, if you would like to join the debate, with the page you are currently listening to muted, simply click that link to join the discussion and express your views on the shape of the Earth. There are a couple of rules in the Hangout. Number 1, please do not swear. If you do, you'll be ejected, and if you are, please don't try to rejoin using sock accounts. You will be warmly welcome back on the next show. Now, it is a bit of a battlefield. There are definitely snipers around, so if you are sniped, obviously feel free to rejoin if you can. Other than that, one more time, if you're new to the channel or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth debate. Last but not least, please share the show as it increases the live audience, which in turn increases the diversity of the people on the panel.
How cold was it on the day that you made the observations, Anthony?
Sorry, Nathan was talking. I couldn't hear you speak.
See, the thing is,
what was the air temperature on
the day?
But when we're accounting for standard refraction on your model, we don't account for the variable of the air pressure or the temperature.
What was the air temperature on the day that you made the observations?
That isn't your maths, though, Paul.
Sorry, Paul. Sorry, just to interrupt you guys. Paul and Rumpus. Sorry, guys. Can you just stop screen sharing while you're in the back and forth? It's giving people epilepsy. Just stop screen sharing unless you specifically want to share something. Thank you.
Just back to that one point. Anthony is determined that he knows the maths and you don't. He knows what's happening with this.
All he's doing is saying he thinks 7/6 is stuck in concrete. He doesn't realise the guy speak function.
Let him explain it.
What's the right way to do it, Riley?
Well, on your maths, it's apply 7/6R and let the arc
continuously
bend
it's
down.
Apply that
yes, it is.
Formula
that's what your maths is. 7. Right. Let me ask you this way: if we were calculating for the gravitational constant, and I went in with my own fandangled set of maths, would you allow it?
That's not an answer to the question you're being asked. Can you answer
the answer to the question is 7/6R and nothing else.
What is the maths described in the curve calculator? How does it work? And what is it telling you?
It's 7/6 of the radius, and it's a continuous arc calculation going down at all times.
What does that mean?
That's gibberish.
What does that mean? But what is going down? The surface of the Earth?
The ballers are going down one by one.
What?
You ballers are going down one by one.
The what?
You can't even explain yourself, can you?
Your first word is not coming through.
Right. What's going down is your calculation. All the time that you put in your distance, that calculation is affecting the hump. It affects the refracted hidden value all the time, and it's always going. Your value's going up because the curve is going down on your maths. 7/6R.
Anthony, do you understand that all it's doing is multiplying something by 7/6 in that calculator? That's all it's doing. It's multiplying.
Do you understand that it's a downward calculation all the time, Rumpus? Yes or no?
Sorry.
Yes or no, Rumpus? Do you understand that it's a value that goes down all the time?
No.
And
You don't understand that.
understand how a tangent affects the increase in drop.
It's got nothing to do with tangent to curved.
It has everything to do with the tangent.
So,
yes, it
Rumpus,
did.
if you don't understand it, why are you arguing it?
You don't understand it.
7/6 is not that difficult.
Right.
Do you want explaining this to somebody who had no idea
solve
what
it then?
refraction was? Do you think the explanation you just gave is sufficient?
Yeah, he has
It's
no clue.
black and white. You are not applying the maths that your model tells you to apply. It's not even intelligence
Again,
based.
what is the maths actually doing? You said it's something's going down. That's not explaining what's happening.
I've told you before many times. I'll say it again, Al.
Is my microphone working?
Yeah,
I can hear you, Al.
Just before you do repeat it, and sorry to interrupt.
All right, well, I've got a question. How
You go ahead in a moment, Ali, bear with me just 1 second. I just want to say hello to Physics Warrior. Good to have you here, Physics Warrior. Can you hear us?
I blame you for my vision getting so clear.
Thank you, Nathan.
Good to see you. Sorry, you go ahead, Ali.
All right, next one. The question is, couldn't you do an equation to show what the atmosphere would have to be to cause the 1,000 foot of refraction? You should be able to do that mathematically, couldn't you? The conditions needed to cause that 1,000 foot of curvature, surely, or refraction, surely you should be able to whip together a nice little mathematical equation.
Ali, who are you asking?
And then we can have a look at the conditions of the day.
I think
and see if it matches. It's only a little.
Paul could probably do that, but the problem is, Ali, there's a fundamental misunderstanding on what the equation we're talking about is actually doing. And Anthony does not understand it, but he's arguing against it.
No, that doesn't matter. Forget what Anthony. It's just I'm asking the question now, so it doesn't matter if we do understand it or we don't. Surely someone.
Ali, we could do that. Yes.
Normally, I would agree, but the problem is this is an ongoing thing for a long time. And I don't think Anthony should be let off the hook for being this way about it.
So that's fine.
Bring it on, Al. I'm here all the time. I will stand up for this all the time.
You're an idiot. Honestly, you really. I can't believe you got an IQ over 100 if you don't understand what we're telling you here.
I mean, you do understand that
I'm
all
telling
you that you're lying about.
To simply multiply a fraction, multiplying by the
You're not going to do the equation then. No, you're not going to do the equation. You're going to still attack Anthony.
Oh yeah, we're doing. Yeah, we're sticking on Anthony. Yeah, I'm not going to go away and let him get away with not understanding something so simple.
All right, okay then, but you will do the equation though, and
it's a bit more fit. It's not straightforward, Ali. I'd have to go.
No, it's not. Understand that. Absolutely understand that. But it'd be good to see. Yeah. What the atmospheric conditions would have to be.
Well, you've got three. Well, the thing is, Ali, you've got three variables.
Brilliant point, Ali.
The pressure. You could change the temperature.
That is a brilliant
you could change
point.
the temperature gradient. So
that is a brilliant point. Let's reverse the maths and let's apply what Ali's just asked. Can somebody do the maths and tell us what the conditions must be to get that level of refraction?
Get back to the answer, which is that you don't know what you're talking about, and if you claim you do.
Let's see if I don't know what I'm talking about. Let's do what Ali's just requested. Reverse engineer the maths.
You do it. You do it, Riley.
As a diversion.
You do it, Anthony.
Well, I'll apply your maths and I'll just do the reverse of 7/6 if you want, because that's what your maths says.
Yeah, that's not
our
maths.
You know, because I would do it if I knew how to do the equations, but unfortunately, I'm not at that stage at the moment. So.
There's anybody on the panel, Ali. Don't worry about
it. With, and you could pick on any of them, so that's a slightly.
Well, there's lots of variables, isn't there? There's about light, the incidence,
pressure,
light, and all that.
Density,
where the
viscosity.
No. You only need three variables. No, the three variables you need to play.
No.
Temperature, pressure.
No, there's four.
The temperature, pressure, and temperature grade. Those are the only three variables in Paul's
equation
that creates this. There are three variables.
Yeah, but the light will be reflected, so it'll be to do with the angle of incidence of the sun.
You don't need that. You don't need that.
Actually, you do.
No, you don't. Not
four variables, not three.
Curve, sit back. I'm talking to someone clever.
It's a distraction to get away from being Riley.
Rumpus, why don't you?
Why should you be cutting in here, Ali?
Yeah, we're trying to sort out.
Because he's entitled to it. It's a flat earth debate.
Well, because I'm trying to stop the discussion.
You're trying to deflect.
Yeah, you're trying to stop it. You just said it yourself. You're trying to stop.
Attacking someone, that's all. And it's got nothing at all.
We're not attacking. Riley is on the attack. And he has no idea why he's attacking.
He is constantly.
That's the point. And that's all he's doing is distraction away from the point.
No, it is the point. Riley is attacking.
And
Yeah,
so
that's what you're doing. Yeah, you're just you're wasting time.
To prove point his assertion.
Proving nothing. It doesn't prove. Proving that Anthony's dumb is dumb does not prove that that photograph's wrong.
It's not about proving he's dumb. It's about getting people to understand how wrong he is. He's making assertions that he is dead wrong about.
If you can tell me how that is relevant to the point in hand, the debate in hand, whether someone's
talking about his assertions being wrong.
You were calling him a dumbass.
He
is. All that.
He is, but this is
Well,
what he's saying is but he's
at some point
it's right. And you all believe he's right when he says the shit that he says. It needs to be established that he is wrong. And if he insists and coming on so many hangouts and putting out all this shit all the time, then he needs to be able to back it up.
I agree with Ali.
He always gets an out, Ali. You're gaining one now. Nathan gives him an out. He always gets gaining out.
No. Let's keep me in it. Let's keep me in it. Let me take over for a minute. Let's do what Ali suggested, and let's reverse the maths and tell us what the conditions need to be to get that level of refraction.
Dying to get on to another subject here, isn't he?
Shift the goalposts.
Yeah. No.
Why can't you?
I'm applying Ali's point because I agree with him. If you guys think I don't understand it and think that your maths is correct, let's show us what the conditions need to be atmospherically to get that level of refraction.
Nope.
There's a physicist in here who can do the maths.
You say it's wrong. Show us the right way, Riley.
7-6R
is your way. That's the only way.
Earlier to determine what would make the correction. It turns out that the value you need is
Nathan.
it was about the value of 2 for the
Nathan.
Instead of 7/6, it came out as 2, which means that K, which is the formula that Paul was showing, would have to be 0.5. Which means then you would then go and then say, well, so then you've got 0.5 equal to K, and then you could reverse engineer what the temperature gradient would have to be to do that. So,
and I've already done that calculation, and it turns out it turns out to be about 0.05 degrees per meter.
Right.
A 20th of a degree
exactly
per meter temperature gradient.
Can you show your workings, please, and I'll be able to get them checked.
Can you show the equation for that? Could you show the equation for that, please, Paul?
I can show you how you do that calculation quite easily.
Yep, but show me the equation that you've done to come to that figure.
I agree. I'd like to see that.
You guys think exactly.
Well, you calculated it, so let's see what you put into it, right?
Okay. What do I put into it? Okay. Let's have a look then.
Well, the person
your input, your data.
Make Anthony do it.
He's not capable of tying shoelaces together, let alone doing this.
He's not capable of doing it. Anthony won't be able to do it. He doesn't understand it.
Yeah, and I'm not capable either.
Well, if you shut up and listen, I'll do it for you.
Listen, you shut your face. Don't talk to me like that. He's trying to
do what you asked,
Ellie. Interruption, okay?
He's trying to do what you asked.
You're ready to listen politely.
It was an accident.
Right, let's just be clear. He's asking for the reverse engineered maths to show what the atmospheric conditions must be to get that level of refraction. Now, Paul, be aware that we both know that I've got access to 2 or 3 mathematicians that can do the maths. So whatever you're going to show now,
that's not a problem.
Then you should know
it's accurate because we can get it tested.
We can teach you how to understand.
Well, are you actually going to let me do the calculation?
I'm waiting for you to do the calculation.
Thank you. Right. Okay. The temperature gradient. I said we needed a temperature gradient of around about 1/20th or a 40th of a degree. I'm going to put in a temperature gradient of 0.05. That's the dt over dh. It's positive. I'm going to now add the 0.0343. So I've added that to the quantity, right? And that equals that. Now I'm going to multiply by standard or roughly atmospheric pressure. Was it a nice day or a terrible day there on the day that you observed, Anthony?
It was glorious.
Okay, so we expect probably a high pressure. 1030 would be close enough, right?
Yeah,
and then temperature-wise, what temperature was it roughly?
30 degrees.
That hot?
30 degrees?
No, it weren't that hot.
I don't think so. I've looked. You mean Fahrenheit or Celsius?
Celsius.
I'd say 26 Celsius. Because it was the end of October.
No, nonsense, because I've looked up the temperature data for St. Bees for October, and the highest temperatures in October for St. Bees are around about 13 or 14 degrees Celsius.
Oh,
well,
that's a
So
cod.
let's put in 13. Let's put in 13 degrees Celsius, shall we? Which is 286 degrees Kelvin, because we need to put our temperature in degrees Kelvin. So we're going to do divided by 286. And then we've got to divide by 286 again because it's T squared. All right. And now we have to multiply by 503. So we multiply by 503, and that gives us a value of K of 0.5039.
Oh, that's about right.
I'm going to remember that.
Yeah.
Right. And that's around about
as
right.
I remember, the value, if it becomes 2, not 1 over 0.5 is 2, I think that gives you about the right answer, actually.
Yeah, you said 5. You said 5. You got it. Yeah. Good call.
Yep. So if I do 1 minus that number, I'll get what? Around about 0.47.
Yeah.
And then if I do 1 divided by 0.47,
it's about 2.
You get a value of around about 2.
Right. So do you understand, Anthony? That's the value you would now stick in Mick West's calculator. You'd replace the 7/6, and instead you'd stick the value of 2 in there. Do you understand? That's what's happening here. You take out the 7/6.
The question that I asked
you
for
eliminate
was what
it,
would be the
and instead you put in 2.1.
Wait,
that's what
the question that was asked was what would the conditions in the atmosphere be necessary to get the refraction that's required to negate the curvature?
Yeah,
That's
and
what
when
the
you put the
question
value
was.
of 2, that will do the correction of the R to give you that difference. But I did it in my spreadsheet of the missing 250 meters. It's about that.
We can do the calculations to show what temperature gradient you would have to make it look completely flat, if you like.
No, I'm asking for the condition. I agree with Ali. What are the conditions required based on your mathematics, which you're not doing at the minute? You're doing the other mathematics, which I agree with, but I don't agree with the 7/6R.
This is what you don't understand, Anthony. This is the mathematics.
This is the mathematics.
Don't you? This is why I keep on saying. You understand the 7/6 will be replaced by that 2.1.
Okay then. Let me go. Let's go through the mathematics. Right. So K, that's the refraction. Yeah. K is the value.
That's the coefficient of refraction.
Yeah, that's a refraction, wasn't it? The K.
Yes.
Right. So we see that's.
Ali, do you understand? Sorry to interrupt.
Okay, what's the 503? Excuse me.
Ali, can I just explain? Sorry to interrupt you. I've got an important point. If you could
let me. What is the
503? I'll help you understand that formula. Do you see?
No, I don't want you to talk to me. I want Paul, because Paul done it there, right? Let me talk to Paul.
Okay, with the RF, he needs to explain to him where that RF comes from.
I understand. Listen. I only need to I just need to ask the questions and I will understand. I'm not a dummy, right? So I don't need any extra help, right? So the value 503, where did that derive from? What is that value 503? What is that number?
From atmospheric theory, fraction theory, we revolve quite you'll have to go to very deep physics to understand where that value came from.
Well, go to the deep physics. I can understand deep physics. Go talk away. Don't show me equations. If you can describe it in words, I can understand it. I understand English.
That's the sound of goalposts being moved.
Yep, big time.
No, it isn't. It isn't. The sound of goalposts being moved is applying 7/6R, getting a figure, and then coming back and saying, "Oh, this is the refraction." When you claim it's based on other refraction, the values are completely different. That's goalposts moving.
Right. What's the number 503? What's the value? Look, there's not a lot. I'm not going to ask a lot of questions. I just want to know the values. I know what the actions or how it's designed. I know this. The calculation. I just want to know, where did the 503 come from?
You would have to be a PhD in physics who understood atmospherics to understand where that came from.
Paul's a physics thing. He can teach me. He's a teacher.
Yeah, but it would require you'd have to be an expert in this. You wouldn't. You'd have to have more material. You'd have to be an expert in this. You'd have to research. You'd have to be doing exams in this.
So you have to be an expert in it, right? So Paul's not an expert in refraction yet. He's talking about it.
He can use the formula. He's just using the formula like I would. He doesn't.
Okay, then. So what does the 503 stand for? I take it P's. Well, what is a perfect
In
normal
physics,
question?
we use lots of formulas that other clever people have derived. So we use them all over the shop. Clever formulas that we ourselves can't derive because it's too
Yeah, but
complicated to do. So,
do you know
or
what though?
we
In
don't happen to
response,
be experts
Rumpus,
in
we
that
in Flat
field.
Earth use evidence.
It's just a number. It'll have it. It'll be a value or something.
Yes,
what
it
is
will
it?
be.
Value.
Well,
Why are they using
he doesn't know off the top of his head. It's a very complicated value.
Are you talking for Paul now? Is it?
Well, I believe
Is
Paul
it?
would agree with me.
All right.
I mean,
What's the value called then? What's the value called so I can Google it? What's that value
Why don't
called?
you go and Google? Why don't you go and Google coefficient of refraction and learn about it yourself?
Yeah.
And
it'd be
you go and
tricky.
do the research instead of asking somebody else to go and do the research for you. Why don't you go and do it?
Yeah, and I will do that. Actually,
You
I'm
go
actually
and find out where the 503 comes from. You go and find out where it comes from.
Yeah, okay. Yes.
I mean,
okay,
Paul, you do agree with me. It's just it's going to be some very complicated maths, isn't it? That's going to be derived from that.
Paul,
exactly.
Paul, that reminded me. That
There is a
reminded me of
lot
yesterday's show.
I think you should start
theory
smoking the
behind
herb or
that.
something, Paul. Start smoking the herb, mate. You need to chill out. Your manners towards other people is disgusting for a grown
Gross
man.
stupidity. You're
'Cause
asking.
I take it you are a grown man.
You might as well be
And I
asking.
take it you're not.
Yeah.
Mm.
You don't understand how the
You've
world
not
works,
that
Ali.
assumption,
Because
like,
you're
they
not
use your
behaving
assumptions
like
to
one.
make- So you follow science perfectly. You make
Have you ever done a
assumptions.
physics
and
exam?
you're
Have you ever
wrong.
done a physics exam, Ali? Have you ever used formulas in a physics exam that you learned because someone told you they were the right formulas?
I've used yeah, well, not physics, but in arithmetic. I've used trigonometry, and I've used it in my job.
Okay, here's a question for you. Then how do you know that the sine theta, how that's calculated? You tell me how you calculate the sine theta of something. You tell me how you've used that. Because I bet you won't know.
What function does it use?
Yes, exactly. You explain to me how the sine function works in trigonometry.
Well, but you need to tell me what it does, and then I can tell you what I use.
You don't know what
in
the
my
sine
job.
function is in trigonometry. You're telling me you
Well,
don't
it's
know.
a way. Is it right? Well, describe it to me.
You hold on. You're telling me you're lecturing Paul about what he should know of value, and you do not know what the sine function is in
It wasn't a
trigonometry.
lecture. That was questions, mate. I don't know what school you went to, but that was questions I was
Right,
asking.
but you're
not
telling me that you do not have the understanding of a 13-year-old who's done trigonometry who knows what a sine function is.
No, I absolutely do. Yeah, I've heard about it.
Oh my god! And
But
I knew this when I was 11.
In the end, how's that relevant to the number 503?
Because you asked Paul to explain this number, and you said, "Well, I
Well,
don't use." You've implied that you don't use numbers unless you understand them. Yet you don't even understand where the sine function comes in basic trigonometry. So
What's
being
this got to do with curvature?
You're using trigonometry, which I presume
it's-
you have done somewhere in your school education,
attack
and you're lecturing Paul that he should know everything, and you don't even
I
know
was
the
not
most
lecturing,
basic function
I
in
did
trigonometry.
not ask that question.
That was a great
I
catch,
just simply
Rumpus.
asked the question.
Thank you. That was a good catch.
Thanks, Tony. I mean, it's incredibly hypocritical.
It's a great show, man.
To demand that other people know every single equation that they use, and you don't even know one of the most basic equations in primary school, first year secondary school maths.
You would at least think the person that was showing you the equation would know to actually explain what it.
No, I wouldn't know it. It's going to be incredibly complicated. Physics is going to be the cause of that particular value of 0.53. You'd have to have a PhD. You have to be a researcher in the subject to be able to derive it, and you'd have to have done a course on it to understand. Paul's not going to know that off the top of his head. You'd have to have someone of an incredible expert to be able to derive that up. Someone who's
it's quite simple, is it not?
Physics.
Well, that's quite a simple equation. The 503. I know the rest of what the rest of.
You said it's a simple equation.
It's a simple equation. But you could derive it then, can you? Ali, you could derive that equation, can you?
Well, I want to derive it. Right, okay, put it up on the screen, right?
Go on, Paul. Put it back on the screen. We've got to see
Yeah,
this.
right. Put it up on the screen, and I'll describe what it does, right? Or what it does. I won't be able to tell you the value, but put it up, and I'll describe it. I understand what the function of that equation is. Stick it up, right? So it's
okay
saying.
To say you guys don't know something. Jeez.
Right. Okay. Listen.
Once.
So anyway, that letter on the beginning is what the wait a minute. That letter on the beginning has been the value of it is derived by the bit after the equal sign. So K equals 500 times P could be pressure. I don't know. divided by, I don't know what T is, but square, right? times, wait a minute, times the equation in the background, which is 0.0343 plus dt over dh. So you divide dt by dh, you add that to 0.34, blah, blah, blah. You times 503, the 503 times the pt over time squared together, and that's your value of k.
Yes.
Correct me if I'm wrong.
What does dt represent?
I said I didn't know what the letters are. Tell me, if you tell me, I'll know. I don't know what the letters mean. I told that when I started, but I've just told you the function and how to work it out. If you told
Ali,
me what d
you
was,
have got the understanding of maths of about a 12-year-old. I would be able to do a better job of describing what that equation is when I was 12. That's the level you're working at. And Anthony's in the same area.
Wait a minute. I still described what it done. And if you gave me values, I could go and do that sum quite easily.
I've never seen that.
You don't know what dt. You don't understand what that d means. As what Paul was getting was about to quiz you about. He was going to ask you what you think that dt over dh means.
Well, d could be d.
Delta.
Well, I would
it's
take
delta
P.
temperature over
Yeah, they didn't
delta
explain.
pressure.
Right. Well, P I would have thought would mean pressure because it usually means
Well, we told you that. You said you didn't know initially, and then I told you it was pressure.
No, you never.
I did. You said, "What's this P?" When you were going through it initially, you said this P, and I said that is pressure because you didn't know what it was. I had to tell you.
Oh, I never heard you say that. I never heard you say that.
Okay, all right, okay, all right, okay.
I would assume that because it's about air density, so I would assume P. Now T, I would be confused because usually in equations that I see it and it means time, and D usually means distance, and that would mean times time. But I don't think that D means distance, and if D means distance, then I would say H means height.
Temperature.
So that would be my guess.
I've never seen this before, right? But it's P is pressure, T is time, and I believe the D is the delta. Is that correct? Delta.
You just said T was equal to time, then.
Oh, sorry, temperature. T equals temperature. D is the delta. And
T temperature, of course, yeah, right, cool.
D is D, T, and DH is delta because it's a variable, changes.
Yeah,
is that correct?
Right, and what's DH? What's DH?
That's the delta of the pressure.
Oh, so H is HPA pressure, yeah.
No, height.
Yeah, H is height.
About 2 minutes remaining. 2 minutes left, guys.
Right, okay,
2 minutes.
that's fine, right, okay, because that's height will be a value of the pressure, because the higher you go up, the pressure gets less, right, okay, fine.
Hey, can I read something real quick in case it hasn't been done? The angle of refraction increases with the coefficient of refraction and with the length of the line of sight.
Yeah.
Thank you. Have a good evening.
Yeah.
But that is inherently the problem.
That's why you only need a tiny, tiny increase in refraction to account.
No.
To account for this missing 250 meters. You only need a very tiny little bit of refraction because it's over 50 miles. You only need a very tiny little bit of extra refraction to account for the missing 250 meters.
Yeah, but we saw on sound these 8 lamps on 8 posts thing that light bends up as well as down. And again, I'll reassert my position while we close. Your maths 7/6R only ever goes down. I know you've cited back different maths to me, and I agree with the maths you've cited back to me, but that isn't the maths for your standard refraction calculator.
And with that, I'm going to say, first and foremost, a huge, massive, enormous thank you to all of the live audience for tuning in and for sharing the show and for hitting the super chat. So massive thank you to all. And of course, a massive, massive thank you to all of the debating panel for making this debate possible. Be sure to like, comment, share and subscribe. I've been Nathan Oakley and I'll see you all in the next video.